Alright, we've got our independent variables. It's time to create our dependent variables for the LGD and the EAD models. In practice, you are only going to be working on one of these models at a time. So in this class, for convenience, we're going to use one dataset for storing the data needed for both models. Let's start with loss given default. Loss given default is the share of an asset that is lost if a borrower defaults. It is the proportion of the total exposure that can be recovered by the lender once a default has occurred. The established approach in practice is to model the proportion of the total exposure that can be recovered by the lender once a default has occurred. This proportion is called recovery rate. From there, the proportion that can't be recovered, or loss given default, can be calculated easily because it equals 1 minus the recovery rate for each exposure. So, how can we calculate the recovery rate in our data? We can find the amount recovered after a default in the column Recoveries. We assume that in our data for defaulted borrowers, the funded amount column reflects the total amount that was lost altogether at the moment the borrower defaulted. So, we can calculate the recovery rate as the proportion of the funded amount that has been recovered. That is, recovery rate equals recoveries divided by funded amount. Let's call the pandas describe method to see what values we get. Great! We can see the mean recovery rate here. The minimum recovery rate is 0, as expected. However, the maximum is greater than 1. Since the recovery rate is a rate, it is bounded between 0 and 1. However, it happens sometimes that we see values falling outside this range due to certain accounting calculations and how the different databases reflect them. In these cases, we can truncate the values that are outside the 0-1 range to either 0 or 1. Let's do that here. So wherever the recovery rate is greater than 1, we assign a value of 1, and where it isn't, keep the existing value. Similarly, wherever the recovery rate is lower than 0, we assign a value of 0, and where it isn't, keep the existing value. Alright. Now, all the recovery rate values are in the natural domain of 0 to 1. And that's it. Recovery rate is our dependent variable for the loss given default model, and we have successfully pre-processed it. Awesome. How about exposure at default? Exposure at default is the total value that a lender is exposed to when a borrower defaults. Therefore, it is the maximum that a bank may lose when a borrower defaults on a loan. On many occasions, the bank has decided to grant an amount of money, but the lender has not disbursed the whole amount. Also, the borrower may have repaid a significant amount of the debt at the time of default. Moreover, for revolving facilities such as credit cards, but also for some consumer loans, the borrower may be able to repay and spend what they had already repaid again up to a certain limit, called credit limit. So the borrower may only have defaulted on a proportion of the original funded amount. That proportion is going to be our dependent variable for the exposure at default model. Most often, the proportion is called credit conversion factor. Then, of course, the exposure at default can be calculated easily because it equals the total funded amount multiplied by the credit conversion factor. Alright. Let's assume that in our data we can calculate that proportion using the total recovered principal column. Naturally, total recovered principal reflects the total payments made on the principal of the loan. Hence, if a borrower defaults, they would only have to repay the funded amount less the payments made on the principal, as this is money they've already repaid. Okay, let's call the proportion from the funded amount that the borrower would need to repay CCF from credit conversion factor. It is equal to the funded amount minus the total recovered principal divided by the funded amount. If all was paid, CCF would be 0. If nothing was paid, CCF would be 1. Let's use the describe method to see what values we get. Alright, the minimum value we get is 0, and the maximum is 1. Good job! Let's export the loan data defaults data frame to a CSV file. In the next lecture, we will discuss the modeling approaches we can use. Thanks for watching.